Open the file 019 Super Spray Follow Path. The follow path suggested the possibility to follow a path, which in this example is a spline helix, which was built by the families of spline, so you can build a helix in this way. Position the cursor here, pick up the mouse, to generate the height of this helix, and subsequently modify the parameters of the helix, for example, the radius 1, or the radius 2. We can modify turns representing the twists of the helix, to create a path. After creating this type of path, we can generate a force with the space warp, which follow a path. The path to follow builds an icon with the representations inside, suggesting the migration of particles in the direction of a flow. The size of the icon, as we have seen in other examples, has no relationship with the end result of the movement of these particles. It is only a graphical representation. As always, we need to do is select this space warp and hook it to particle system. Or vice versa, select the particle system and hook to the space warp. The procedure is similar. As soon as I hooked, observed that the particles have had a moment of hesitation, then there is already a change, even they do not know which path they must follow. In fact, inside to this space warp, he asks me to select a shape. So the shape are the spline helix. In fact, if they select an object of any other nature, he cannot select it when I will make a click with pick shape. He will give me the opportunity to specify a number of parameters to change the trend of the objects, which in this case are the spheres, emitted by the super spray. It can be observed already in the first part. We have a small ball that follows the path. We need to do is set the correct parameters. I advise you to change the animation in time, to observe what actually is happening, and begin to set these parameters. Now decrease the icon, because it disturbs the view. What is important is to see the path. In the path we start with 0 frame and a travel time, that is, a crossing time of a change, and the last frames, then the last frame. Here we have 200 frames. In fact, after the 100 frames, we can observe that the particles are fired in all directions, because they no longer follow this spline, and start the classic emitted. So the first thing we must to do, if we want to set the animation, with the consequent movement, in relation to the path for all frames, we need to set these 200 frames. But then, we can see that at some point, the balls start at their disposal in space. Here it is. Then what should we do? First of all, set the first frame. Even if we set the 0 frame, it is not enough, because we owe to anticipate this kind of animation. Then we owe to go back and anticipate the animation to a negative frame. In this case, with the negative frame, I already have a negative positions of the balls on the path. Here it is. The travel time is also a very important factor, because increasing the travel time, in this case, I realize that the balls follow best this path. Here I set it to 100, then up to frames 100 we have a travel time correct. Then after the spheres follow the path, another hypothetical spiral. If imposed at 200, the balls, what will they do? Follow this path correctly until frame 200. So it's a setting of the birth and the time, where the balls must remain on the spline, and the last frame, where I want to see this kind of animation on the balls, otherwise they are then shipped in other directions. So when we know what is the length of the animation, and we want to replicate this type of path, here's what we need to do. These are settings that change the position of the balls. In this example are the particles, in relation to an offset of the spline, or in relation to a parallel position. Simply change it, to decide what is the correct position. If I do not like this and I prefer this one, or vice versa. Then all changes in relation to how many particles there are in the representation, as we see later. The constant speed represents a constant speed of the animation, while if disable the constant speed, I obtain a different animation. These are settings that you appreciate much more when we have more particles in the animation. To see the differences in convergence and divergence. What we want now is to observe the movement on the spline, and you understand how this movement, we can successfully create the settings of these parameters, then the start frame, and the travel time. Here we have a variation that can alter the change of time. In this example, what happens? The balls are moving, however, move in groups, less equidistant, because you change an effect of chaos. Then at a certain moment the balls will come out. If I want a provision equidistant, what I ought to do is this. I have saved this file as 020 super spray follow path end.